Today's lesson is on adding and subtracting polynomials. So two terms are like terms if they have the same variable or really variables raised to the same exponent. So which of the following are like terms? Well, we have 3x and 9x. X and x. Are x and x like terms? Yeah, they are. The next one we have 3x squared and 9x cubed. X squared and x cubed, are they the same? Well, they're not. So these are not like terms. So they wouldn't be able to be added, okay? How about the next one? We have x squared and x squared. So 4x squared and 2x squared are like terms. How about the next one? We have x and y. 5x and 3y. The x and the y are not the same letter. So they're not the same variable raised to the same exponent. So these are not like. And how about the next one? xy squared and x squared y. This is really tricky. They both have an x and a y and a squared, but the squared isn't in the same place. xy squared means x and then 2 y's, whereas x squared y means 2 x's and then 1 y. These are not like. All of the variables have to have the same exponents, so these are not like. Now, in order to add or subtract like terms, all you're going to do is simply add the coefficients. That means the number in front, and leave the common variable the same. Remember, they have to be the same in order to add them. So we're just going to leave the variables the same. So on our first problem, we have 3x squared plus 9x squared. Are the x squareds the same? Yes, they are. So what are we going to do with the x squareds? Nothing. Leave them the same. So we have 3x squared plus 9x squared. If we take the 3 plus the 9, that gives us 12x squared. Our next example, we have x squared y, 5x squared y plus 7xy squared minus 3x squared y. Which of these are like terms? Well, x squared y and x squared y are like terms. So those two can combine. So I'm going to take the coefficients and add or subtract them. 5 minus 3 gets us 2, and leave the x squared y exactly the same. Now, what happens to the other term? Well, not much. It's just going to come down. Plus 7xy squared. These two can't add now because they're not like terms. One's x squared y, one's xy squared, so then you're completely done. On the next one, x squared minus 3x minus 5x plus 15. The only two that are like terms are the two that have just plain x. So those two can add together. So I have minus 3x minus 5x. That adds to minus 8x. Notice the x stayed the same. This is not like when you were multiplying variables and you added the exponents. A lot of people want to do that because we did that earlier in a previous lesson. But these are adding the whole terms. We have two terms. We're not multiplying, so we're not adding the exponents. The x squared just comes down. The plus 15 just comes down. And that's our answer. So to add polynomials, just combine like terms. Now, some books will call it similar terms. Similar or like, it's the same thing, okay? But when you're subtracting polynomials, what I want you to do is distribute the negative from the subtract sign to the second parentheses. Then you can combine like terms. Let me give you some examples of that. When we have adding polynomials on the left column and we have subtracting on the right, when you're adding, all you're going to do is find like terms. So 2x squared and 5x squared, that adds up to 7x squared. Next we have plus 3x minus 6x. Those are like terms, and they add and you get minus 3x. And then last we have plus 4 minus 3. those are like terms because they're both numbers, and that leaves me with plus 1, and that is all you have to do when you're adding. Now, on the other side, with subtracting, you have one extra step here. Because there's a subtract sign, I need to distribute that negative all the way through to the second parenthesis. So we're not just subtracting the first term, we're subtracting every single term. So this gets me minus x squared minus 3x minus 7. This is really important to do, because if you don't distribute the negative, most likely you'll only put the negative on the first term, and then that's not going to be correct. So on this problem, we have like terms here, 5x squared minus, and there's an invisible 1 in front of that x squared. So 5x squared minus 1x squared gets me 4x squared. Next, I'm looking for more like terms. I've got plus x here and minus 3x. Those are like terms. So I can add those, and positive 1x minus 3 is negative 2x. And then lastly, with my numbers, I'm looking for more like terms. Plus 2 minus 7 are like terms. So I'm going to subtract them and get negative 5. So notice that there's one extra step when you're subtracting versus when you're adding. Adding, you can just go straight for it. Subtracting, you need to distribute the negative, and then you can add or subtract like terms. All right, the next one is adding. So because there's a plus, I can just go straight for it. X cubed doesn't have any other like terms. It's the only term out there that has a cube in it. So I'm going to just write 5x cubed and look for more like terms. The next set of like terms I'm looking for are squares. Negative 2x squared and positive 1x squared. There is an invisible 1 in front of that, so negative 2 plus 1 is negative 1x squared. And then I'm looking for more like terms. I have 3x over here, but there's nothing else that has an x only. So that's it for that problem. So I'm going to just add 3x. And then my last one, I'm looking for anything else that's like. Constants. I have a plus 9 and a plus 7, and that is going to get me a plus 16. All right, one more problem. It's a negative, so that means I'm going to distribute my negative first. So negative times a negative 3x squared is a positive 3x squared. Negative times a negative 2xy is a positive 2xy. And a negative times a positive 4y squared is a negative 4y squared. Notice that the first parentheses just comes down. Now we can look for like terms. We have 5x squared and positive 3x squared. So when I add those together, that's going to get me an 8x squared. All right, now I'm going to look for xy terms. We have negative xy and positive 2xy. Don't forget that in front of that negative xy, there's like a 1 here. So that's negative 1xy. So negative 1xy plus 2xy, that's going to add to a positive 1xy. And then lastly, I'm looking for y squareds. So here I have 6y squared and negative 4y squared. So negative 6 minus 4 more. So because they're both the same sign, I add the values and get 10y squared and keep their sign negative. None of these, my answer, are like terms, so I know I am done. All right, the next thing I'm going to show you is similar to what we're doing here, except it's just writing the polynomials vertically. You don't have to do it this way, but if some people like it better this way, so I'm going to show you just a different way of doing the same problem. Notice that this is the exact same problem as the first one we did, so we're hoping to get the same answer. I'm just showing you a different way of writing it. So we could take 2x squared plus 3x plus 4, and notice this is going to be like our x squared column, this is going to be our x column, and this is going to be our number column. So underneath, I'm going to write plus. The 5x squared is going to go underneath the other x squared. So what I'm doing here is I'm just lining up all the like terms, line up all the x's, line up all the numbers, and then I can just add down. 2 plus 5 is 7. Keep the x squared the same. 3 minus 6 is negative 3. Keep the x the same. 4 minus 3 is 1. and then that's the answer. If you scroll up, you can see that that's the same answer that we had above for the same problem. And of course it's the same. It should be the same. It's the same problem, but this is just a different way of writing it. Now we're going to do the subtract vertically. So I have 5x squared plus x plus 2. And I'm going to distribute my negative because there's a step there that I have to do. But when I distribute it, negative times x squared is negative x squared. I'm just going to put it right up underneath the other x squareds so that I've got all my x squareds in a column, all my x's in a column, and my numbers in a column. So I distribute negative times 3x and put that right up underneath the other x, negative 3x. Negative times 7, that's negative 7, and put that right underneath the other number. So we have 5x squared minus that invisible 1x squared, that's 4x squared. Positive 1 minus 3, that's negative 2x. And 2 minus 7, that's negative 5. And that's my answer. Notice that this was the same problem that we did above. I did that on purpose just so you could see that there's two different ways of doing the same problem. If you like writing it vertically, great, do it. If you like writing it horizontally, great, do it. It doesn't really matter to me. Whichever one you like better. And this concludes our lesson on adding and subtracting polynomials.